Calculus is a terrific subject to learn. This is one of the most profound statements made by students who offered the subject or who are offering the subject. And this causes a lot of bother for the young students who are about to start taking the course. In fact, some students quit math entirely at this point, probably because of the exaggeration or the fear. If you are watching this video, probably because you want to start taking calculus, then I would like to encourage you to put yourself together and be passionate. As long as you can apply yourself, there's no reason why you can't learn the subject, as most of the concepts involved are quite beautiful and interesting. In this video tutorial, I would like to introduce to you the concept of calculus. So first thing first, what exactly is calculus? Calculus is a branch of mathematics that deals with change. Unlike other branches of mathematics, probability that deals with measures of uncertainty, geometry that deals with measures of shapes, and so on. Calculus deals with change. So which change are we talking about in essence? Let's look at that in details. Consider a circle. Now let's take for instance, we don't know how to determine the area of the circle, but we do know how to determine the area of a polygon, starting from the one with three sides, which is known as triangle. Now, you notice that we can always inscribe a triangle into the circle. Now, if we determine the area of the triangle, you notice that it won't be that close to the area of the circle due to some spaces left over. Now, things get much more interesting when we begin to increase the size of the polygon from 3 to 4 to 5 to 6 to 7 and so on. And notice that if we tend to determine the area of those polygons in each cases, then at some point in time, the area of the polygon will be approaching the area of the circle. In fact, at an infinite number of sides of polygon, the area of the polygon will be equals to the area of the circle. In calculus, this approach is what we call the limit, and its function is to help us to predict the value of something when it is approaching some other thing else. So therefore, mathematically, we can say that the limit as the number of sides of the polygon is approaching infinity of the area of the polygon in each cases, then these will be equals to the area of the circle, which I represent as a sub c. Hopefully, you got that. Let's talk about the second case of calculus. Consider the curve of y equals x squared. What if an object starts on the curve at point A? Notice that it will have its corresponding coordinates and then move all the way to point R. Point R will also have its own corresponding coordinates. But we really don't have interest in the coordinates. What if we want to determine the steepness of the object? Notice that we will need to first draw a line called a secant line that will join the 2 points A and R. Now, since the line is a slant line, we can use it to form a right angled triangle, so as to be able to determine the slope or steepness of the object while moving from point A to point R. So, mathematically, to determine the slope of the object, here is what we need to do. The slope equals the change along the y-axis of that object divided by the change along the x-axis of the object. Notice that the object has changed its position along the x-axis, and similarly, when it was at point A, it has changed its position along the y-axis. So determine that change and then divide it respectively gives us the slope or the steepness of that object. And notice that there will now be another point C over here, which will be serving as the vertex for the endpoint of the right angled triangle. Now, what would happen when changing x begin to approaches 0? You notice that as changing x approaches 0, then the change in y also approaches 0, but not like that of changing x. Similarly, the secant line begins to become a tangent line gradually. In fact, when changing x is exactly 0, when it is almost 0, then the secant line becomes a tangent line. So therefore, mathematically, we can say that the limit as the change in x approaches 0 for the change in y over change in x, that gives us the slope of a tangent line. And since a tangent line is a straight line, it means when an object changes from one point to another point on the tangent line, its slope will remain the same. This approach is what we call the differential calculus, and its function is to help us to understand that we can always determine how a particular quantity will be changing with respect to another one. As you can see, as changing x is approaching 0, changing y is also approaching 0. So we can always determine how y will change as x is changing. So let's consider the third case of calculus. In this case, we want to consider a function of y equals x squared minus x plus 5. Here is the graph on the board. Now, what if we select two regions, point A and point B, along the x-axis? Notice that there will be a space, there will be a region bounded between that function and the x-axis. Now, what if we are willing to determine the area of the region bounded by that function and the x-axis? Notice that there is no particular or specific formula in geometry that can help us to do that. However, we can still make use of our knowledge in geometry. Since we know how to determine the area of rectangles, we can inscribe some amount of rectangles into the region until we have an approximate answer. Now, when we begin with 3 rectangles, notice that if we determine the area of these rectangles and then sum them up, due to some lags, these regions left over within the region and outside the region, we can't get the estimate or the right area of the rectangle of the curve or of the region. However, if we tend to increase the rectangles or the field in rectangles, notice that as the rectangles increases, if we tend to determine the sum of the area of those rectangles as an infinite number of field in rectangles, the area of those rectangles, typically the sum will correspond to the area of the region. As you can see, as rectangles get much more bigger, then it tends to fit in the region. This approach is what we call integration or integral calculus. And one of its functions is to help us to understand that we can determine the area of a curve by making use of our knowledge in geometry. So mathematically, we can say that the sum of the area of the infinite number of fields in rectangle, which can be represented as limit as n approaches infinity, of the area of the rectangles equals to the area. And these 3 concepts together is what makes us calculus. All other concepts will be refocusing back to each of these discussed concepts. Now you know what you should be expecting from your calculus class. Notice that either differential calculus, integral calculus, or the limits, all the concept or the basic idea behind it is to help us to understand that we can always do something infinite many times and get a finite answer. So buckle your shoe and put yourself together. Let's go and learn some calculus. Hopefully you find this content helpful. Thanks for watching. See you guys in the next video. Bye for now.